Okay, I hope that theorem 6.2.2 reminds you of a previous theorem that we saw together in chapter 2. As a matter of fact, some of these terms are exactly the same and in the same order as that table from section 2 point whatever it was. The only difference in this table and the other table is that instead of using the V and I'm using the union, and instead of using the little upside down V, I'm using the intersection sign. So that's major difference here, okay? We're gonna actually prove some of these theorems again in the next few minutes, but as a reminder, how do you show that two sets are equal? In order to show two sets are equal, you have to show that X is a subset of Y and Y is a subset of X. We did it once before, but I'm gonna do that again here. So example 3 says show that this massive A union A intersect B is the same thing as the A. This was, by the way, one of these properties that we call absorption laws, example number 10. So we're going to do the proof, and the proof is going to consist of basically saying first, let A and B be any sets. And we're going to start with proof 1. Proof of 1 is going to be where we show that A union A intersect B is itself a subset of A. Okay, this is what I want to show with proof 1. In order to do that, I'm going to pick an element X from the A union A intersect B. Now, by choosing the element X from there, then what do I know? Then I'll know that either X came from the first set A or the X came from the A intersect B. I really don't know which one it is. This is because of the definition of union, so by definition of the union. And since I don't know whether it came from the first set or the second set, I have to do case 1, case 2. So case 1, if the element X came from A, but not from the other one. So basically pretend like this one doesn't exist and show that the proof will still be true. So if X is in A, then we are finished. We are done. Why are we done? Because remember, the whole purpose of the problem right now is to show that you're a subset of A. If your X is already in A, then your X is already in A, and so we're done. So the A union A intersect B is automatically a subset of A. So we got lucky there. Now, what about the other case, case number 2? So case number 2, basically, we're gonna pretend that X came from A intersect B, but not from the A. So, well, then by definition of intersection, we can say that X was in A and at the same time X was in B. By intersection, if you're in A intersect B, then you're in the first set and automatically in the second set. And so we are finished again. Because remember, the whole point of this was to show that if you're inside of the intersection of A and B, then you're automatically part of the A. But, you know, if you're in the intersection of A and B, you're automatically inside of A, and that's it. We're finished. So, proof 1 is basically now done. If you're in A, then you're already in A. If you're in A intersect B, then you're going to be in A automatically. So this is the QED of proof number 1, okay? Now, we're going to do proof number 2 on another separate page. So proof 2 is here. And what are we doing in proof 2? In proof 2, we want to show that A is a subset of A union A intersect B. Okay, that's what we want to do here. And to do that, I'm going to let the X come from the A. Like I said, I'm going to pick it in A to convince myself somehow that it's going to be part of the bigger set. But if you're in A, then your X is in A or any other set in the world that you can think of, right? Pick whatever you want. In particular, I'm going to choose A intersect B. Remember, because this is a disjunction property, if you're truly in A, and whether you're truly or not in A intersect B, it does not matter, your disjunction is still going to be a true statement. So if you're in A, you can tag on anything else you want, okay? But this means that now X is in A union A intersect B. This is by definition of the word union. But then this is basically the end, because if you're in the union, then we are finished. We are done, because we are saying now that A is a subset of A union A intersect B. And this is the end of proof 2, so QED of 2. So to wrap it up, since in proof 1 we showed that A union A intersect B is a subset of A, and in proof 2 we said that A is a subset of A union A intersect B, then by the set equality we know that A union A intersect B is identical to set A. And that's the end of the proof, the original proof at the very start.